Question 261. At Dress4Win, an operations engineer wants to create a low-cost solution to remotely archive copies of database backup files. The database files are compressed tar files stored in their current data center. How should he proceed? A. Create a cron script using Xutil to copy the files to a cold line storage bucket. B. Create a cron script using Xutil to copy the files to a regional storage bucket. C. Create a cloud storage transfer service job to copy the files to a cold line storage bucket. D. Create a cloud storage transfer service job to copy the files to a regional storage bucket. The best answer is option A. White heavy checkmark why option A is correct. 1. Cold line storage is the most cost-effective option for long-term, infrequent access data like database backups. 2. Using a cron job with Xutil provides O. Automation for regular backups. O. Minimal cost since Xutil is free and cold line is the cheapest storage option. 3. Low complexity. A simple cron job can continuously push files to the cloud without any third-party tool or complex configurations. Why other options are incorrect? Option B. Regional storage is designed for high performance and frequently accessed data, not for archival purposes. Using regional storage would result in higher storage costs, making it less suitable for long-term database backups. Option C. Cloud storage transfer service is ideal for one-time large-scale data transfers or recurring transfers between cloud storage buckets. However, since the backup files are generated daily weekly in the data center, using the transfer service for continuous, small-scale transfers is unnecessary. It would also introduce additional operational overhead compared to a simple Xutil cron job. Option D, same as option C, using a cloud storage transfer service for regular database backups is overkill. Regional storage would again increase costs unnecessarily, which contradicts the goal of a low-cost solution. Question 262. Dress4Win has asked you to recommend machine types they should deploy their application servers to. How should you proceed? A. Perform a mapping of the on-premises physical hardware cores and RAM to the nearest machine types in the cloud. B. Recommend that Dress4Win deploy application servers to machine types that offer the highest RAM to CPU ratio available. C. Recommend that Dress4Win deploy into production with the smallest instances available, monitor them over time, and scale the machine type up until the desired performance is reached. D. Identify the number of virtual cores and RAM associated with the application server virtual machines, align them to a custom machine type in the cloud, monitor performance, and scale the machine types up until the desired performance is reached. The best answer is option D. White heavy checkmark why option D is correct. Identifying current virtual cores and RAM ensures you have a baseline understanding of the application's resource requirements. Creating a custom machine type allows Dress4Win to avoid underutilization or over-provisioning of resources. Monitoring performance after deployment ensures Dress4Win only uses resources that align with their actual workload, optimizing cost and performance. Scaling up or down based on usage patterns keeps the infrastructure cost-efficient and adaptable. Crossmark why other options are incorrect. Option A. Simply mapping physical hardware cores and RAM to the nearest predefined machine type is not optimal. It could lead to over-provisioning or under-provisioning since cloud environments scale differently than on-premise infrastructure. It also ignores the benefits of custom machine types. Option B. Recommending the highest RAM to CPU ratio without understanding the application's actual requirements is inefficient. This approach could lead to unnecessary costs or performance bottlenecks if the application is CPU-intensive. Option C. Deploying the smallest instances available and scaling up is inefficient and risky for production workloads. This approach can lead to downtime, performance degradation, and higher operational overhead during peak usage. It is not a best practice for migrating established workloads. Question 263. As part of Dress4Win's plans to migrate to the cloud, they want to be able to set up a managed logging and monitoring system so they can handle spikes in their traffic load. They want to ensure that the infrastructure can be notified when it needs to scale up and down to handle the ebb and flow of usage throughout the day. Asterisk their administrators are notified automatically when their application reports errors. Asterisk they can filter their aggregated logs down in order to debug one piece of the application across many hosts. Which Google Stackdriver features should they use? A. Logging, alerts, insights, debug. B. Monitoring, trace, debug, logging. C. Monitoring, logging, alerts, error reporting. D. Monitoring, logging, debug, error report. The correct answer is C. Monitoring, logging, alerts, error reporting. Explanation. The key requirements from DRESS4 Win are: automatic infrastructure scaling based on traffic load, automatic notifications to administrators when errors occur, ability to filter logs to debug a specific part of the application. To meet these requirements, the following Google Cloud's Operations Suite, formerly Stackdriver, features are most suitable. Monitoring monitors infrastructure metrics, CPU, memory, network, etc., and triggers alerts based on predefined conditions, such as traffic spikes, CPU usage, or memory consumption. This helps ensure the infrastructure scales up and down as needed. Logging collects logs from all application components. It allows aggregating logs across multiple instances, enabling developers to debug a particular part of the application. Alerts triggers notifications to administrators based on error events or any other custom-defined conditions. This ensures that any critical application issues are promptly reported. Error reporting automatically captures, aggregates, and notifies administrators of application errors. It also groups similar errors to reduce noise and helps developers debug efficiently. Why other options are incorrect? Option A, logging, alerts, insights, debug. Incorrect because insights is not a feature in Google Cloud Operations Suite, Stackdriver. Also, debug is used for code-level troubleshooting, not infrastructure monitoring or scaling. Option B, monitoring, trace, debug, logging. Incorrect because trace is primarily used for latency analysis in applications but does not facilitate error notifications or infrastructure scaling. Trace does not fulfill the requirement of triggering alerts or scaling infrastructure. Option D, monitoring, logging, debug, error report. Incorrect because error report is not a valid feature in Stackdriver. The correct feature name is error reporting. Also, debug is not responsible for scaling infrastructure or handling traffic spikes. Question 264. DRESS4 Win would like to become familiar with deploying applications to the cloud by successfully deploying some applications quickly, as is. They have asked for your recommendation. What should you advise? A. Identify self-contained applications with external dependencies as a first move to the cloud. B. Identify enterprise applications with internal dependencies and recommend these as a first move to the cloud. C. Suggest moving their in-house databases to the cloud and continue serving requests to on-premise applications. D. Recommend moving their message queuing servers to the cloud and continue handling requests to on-premise applications. The correct answer is A. Identify self-contained applications with external dependencies as a first move to the cloud. Explanation: DRESS4 Win wants to quickly deploy some applications to the cloud to become familiar with the process. The best approach is to start with self-contained applications that times do not have complex internal dependencies, like database connectivity, microservices interactions, or legacy dependencies. Times can operate independently or rely only on external APIs or services. Times can be quickly deployed, tested, and validated without significant infrastructure changes. This allows DRESS4 Win to gain confidence in cloud deployment while minimizing risk and complexity. Why other options are incorrect? Option B. Identify enterprise applications with internal dependencies and recommend these as a first move to the cloud. Incorrect because enterprise applications often have multiple interdependent components, making cloud migration complex and risky. DRESS4 Win wants a quick and easy deployment, so starting with simpler, self-contained applications is more practical. Option C. suggest moving their in-house databases to the cloud and continue serving requests to on-premise applications. Incorrect, because moving the database first without moving applications can increase latency, cause data synchronization issues, and significantly slow down application performance. This is not a fast and easy migration. Option D, recommend moving their message queuing servers to the cloud and continue handling requests to on-premise applications. Incorrect, because message queues are typically core infrastructure components that facilitate communication between different applications. Moving them first could break the internal workflow and impact application availability. Question 265. Dress4Win has asked you for advice on how to migrate their on-premises MySQL deployment to the cloud. They want to minimize downtime and performance impact to their on-premises solution during the migration. Which approach should you recommend? A. Create a dump of the on-premises MySQL master server, and then shut it down, upload it to the cloud environment, and load into a new MySQL cluster. B. Set up a MySQL replica server slave in the cloud environment, and configure it for asynchronous replication from the MySQL master server on-premises until cutover. C. Create a new MySQL cluster in the cloud, configure applications to begin writing to both on-premises and cloud MySQL masters, and destroy the original cluster at cutover. D. Create a dump of the MySQL replica server into the cloud environment, load it into Google Cloud Data Store, and configure applications to read-write to Cloud Data Store at cutover. The correct answer is B. Set up a MySQL replica server slave in the cloud environment, and configure it for asynchronous replication from the MySQL master server on-premises until cutover. Explanation: Dress4Win wants to migrate their MySQL database to the cloud with minimal downtime, minimal performance impact. The best way to achieve this is by using asynchronous replication, where a MySQL replica slave is created in the cloud environment. It continuously synchronizes data from the on-premises MySQL master with minimal latency. During cutover, the application simply switches to the cloud MySQL, minimizing downtime. This method ensures near zero downtime during migration. Minimal performance impact because the application continues using the on-premises database until cutover. Quick rollback if any issue arises during cutover. Why other options are incorrect? Option A. Create a dump of the on-premises MySQL master server, and then shut it down, upload it to the cloud environment, and load into a new MySQL cluster. Incorrect, because high downtime during migration. Application will remain unavailable until the dump is restored and the new cluster is set up. This contradicts Dress4Win's requirement for minimal downtime. Option C. Create a new MySQL cluster in the cloud, configure applications to begin writing to both on-premise and cloud MySQL masters, and destroy the original cluster at cutover. Incorrect, because dual writes, writing to both on-premise and cloud MySQL, can cause data inconsistency. Managing two master databases increases complexity and risk. It also causes performance degradation for the on-premise database. Option D. Create a dump of the MySQL replica server into the cloud environment, load it into Google Cloud Data Store, and configure applications to read-write to Cloud Data Store at cutover. Incorrect, because Cloud Data Store is a NoSQL database, whereas MySQL is relational SQL. Directly migrating to Cloud Data Store would require application refactoring, which increases downtime and operational complexity. This approach does not fulfill the goal of minimizing downtime and performance impact. Question 266. Dress4Win has configured a new uptime check with Google Stackdriver for several of their legacy services. The Stackdriver dashboard is not reporting the services as healthy. What should they do? A. Install the Stackdriver agent on all of the legacy web servers. B. In the Cloud Platform console, download the list of the uptime servers' IP addresses and create an inbound firewall rule. C. Configure their load balancer to pass through the useragent HTTP header when the value matches Google Stackdriver monitoring uptime checks, https://cloud.google.com/monitoring. D. Configure their legacy web servers to allow requests that contain useragent HTTP header when the value matches Google Stackdriver monitoring uptime checks, https://cloud.google.com/monitoring. The correct answer is B. In the Cloud Platform console, download the list of the uptime server's IP addresses and create an inbound firewall rule. Explanation: Google uptime checks are performed from Google Cloud's monitoring servers located worldwide. If Stackdriver, cloud monitoring, is not reporting services as healthy, it is likely that the legacy services are blocking incoming requests from these monitoring servers due to firewall restrictions. To resolve this, download the list of Google Uptime Check IP addresses from the Cloud console. Create an inbound firewall rule to allow traffic from these IPs to the legacy services. This ensures that Google's monitoring services can reach the application servers and verify their health. Why other options are incorrect? Option A. Install the Stackdriver agent on all of the legacy web servers. Incorrect because the Stackdriver agent is used for logging and metrics collection, not for uptime checks. Uptime checks work externally by sending HTTPS requests to the service, so installing the agent will not resolve the issue. Option C. Configure their load balancer to pass through the useragent HTTP header when the value matches Google Stackdriver monitoring uptime checks. Incorrect because load balancers do not block or modify useragent headers by default. If the uptime check traffic is blocked, it is likely due to firewall rules, not missing useragent headers. Option D. Configure their legacy web servers to allow requests that contain the useragent HTTP header when the value matches Google Stackdriver monitoring uptime checks. Incorrect because useragent filtering is not a common default security setting. Most likely, the issue is with firewall rules blocking Google's monitoring IPs, not the useragent. Conclusion: the best solution is to allow Google's uptime check IPs through the firewall so that cloud monitoring can access and verify the service's health. Question 267. As part of their new application experience, Dress4WM allows customers to upload images of themselves. The customer has exclusive control over who may view these images. Customers should be able to upload images with minimal latency and also be shown their images quickly on the main application page when they log in. Which configuration should Dress4WM use? A. Store image files in a Google Cloud storage bucket. Use Google Cloud Data Store to maintain metadata that maps each customer's ID and their image files. B. Store image files in a Google Cloud storage bucket. Add custom metadata to the uploaded images in cloud storage that contains the customer's unique ID. C. Use a distributed file system to store customers' images. As storage needs increase, add more persistent disks and/or nodes. Assign each customer a unique ID, which sets each file's owner attribute, ensuring privacy of images. D. Use a distributed file system to store customers' images. As storage needs increase, add more persistent disks and/or nodes. Use a Google Cloud SQL database to maintain metadata that maps each customer's ID to their image files. Correct answer: A. Store image files in a Google Cloud storage bucket. Use Google Cloud Data Store to maintain metadata that maps each customer's ID and their image files. Explanation: Google Cloud Storage is the best choice for storing image files because it is highly scalable, cost-effective, and provides low-latency access. Using Google Cloud Data Store to store metadata ensures efficient retrieval of image details, mapping each customer's ID to their respective files. This approach allows for quick lookups, enabling customers to access their images without delay. Why other options are incorrect? Option B is incorrect because while storing images in cloud storage is correct, using custom metadata within cloud storage alone is not the best approach for managing structured relationships. Cloud Data Store provides better querying capabilities for efficiently mapping user IDs to images. Option C is incorrect because using a distributed file system with persistent disks increases management overhead and does not offer the same scalability, durability, and availability as cloud storage. It is also not optimized for serving images at scale. Option D is incorrect because using a relational database like Cloud SQL to store metadata is not ideal for this use case. Cloud Data Store, a NoSQL solution, is more efficient for managing metadata due to its high availability and automatic scaling. Question 268. Dress4Win has end-to-end tests covering 100% of their endpoints. They want to ensure that the move to the cloud does not introduce any new bugs. Which additional testing methods should the developers employ to prevent an outage? A. They should enable Google Stackdriver Debugger on the application code to show errors in the code. B. They should add additional unit tests and production scale load tests on their cloud staging environment. C. They should run the end-to-end tests in the cloud staging environment to determine if the code is working as intended. D. They should add canary tests so developers can measure how much of an impact the new release causes to latency. The correct answer is B. They should add additional unit tests and production scale load tests on their cloud staging environment. Explanation. Dress4Win is moving to the cloud and already has 100% end-to-end test coverage for their endpoints. However, simply running end-to-end tests is not enough to ensure that the migration does not introduce any new issues. To prevent outages, the developers should add additional unit tests to validate smaller components and isolate potential bugs in the cloud environment. Perform production scale load tests to simulate the expected traffic and check whether the cloud infrastructure can handle it. This is critical since cloud environments may behave differently than on-premises setups under high load. This combination will help detect scalability, performance, and stability issues that may not be caught by end-to-end tests. Why other options are incorrect? Option A. Enable Google Stackdriver Debugger on the application code to show errors in the code. Incorrect because Stackdriver Debugger is useful for real-time debugging in production, but it does not prevent outages or identify scalability issues during migration. Debugging does not simulate production-scale traffic. Option C. Run the end-to-end tests in the cloud staging environment to determine if the code is working as intended. Incorrect because end-to-end tests alone do not simulate high production traffic or uncover scaling issues. Additionally, they do not validate infrastructure performance during peak load. Option D. Add canary tests so developers can measure how much of an impact the new release causes to latency. Incorrect because canary tests are useful during incremental rollouts of new features, but they do not provide insights about scalability or cloud infrastructure performance. Canary tests focus more on feature impact, not cloud migration stability. Question 269. You want to ensure Dress4Win's sales and tax records remain available for infrequent viewing by auditors for at least 10 years. Cost optimization is your top priority. Which cloud services should you choose? A. Google Cloud Storage Cold Line to store the data, and Xutil to access the data. B. Google Cloud Storage Nearline to store the data, and Xutil to access the data. C. Google BigTapped with US or EU as location to store the data, and gCloud to access the data. D. BigQuery to store the data, and a web server cluster in a managed instance group to access the data. Google Cloud SQL mirrored across to distinct regions to store the data, and a Redis cluster in a managed instance group to access the data. The correct answer is A. Google Cloud Storage Cold Line to store the data, and Xutil to access the data. Explanation. The key requirements are: store sales and tax records for at least 10 years. Ensure cost optimization is the highest priority. Data will be accessed infrequently, only for audits. Google Cloud Storage Cold Line is the best choice because lowest storage cost for long-term archival, ideal for 10 years. Designed for infrequent access, making it perfect for audit logs. Durable and highly available for data that may rarely be accessed but must be stored reliably. Access via Xutil is simple and cost-effective. Why other options are incorrect? Option B. Google Cloud Storage Nearline to store the data, and Xutil to access the data. Incorrect because nearline storage is designed for monthly access, which is not the case here. The data will be accessed rarely, only for audits, making cold line storage a better and cheaper option. Option C, Google Bigtable with US or EU as location to store the data, and gCloud to access the data. Incorrect, because Bigtable is designed for low latency, high throughput workloads. Storing tax records in Bigtable is unnecessary and expensive for long-term archiving. Option D, BigQuery to store the data, and a web server cluster in a managed instance group to access the data. Google Cloud SQL mirrored across two distinct regions to store the data, and a Redis cluster in a managed instance group to access the data. Question 270. The current Dress4Win system architecture has high latency to some customers because it is located in one data center. As of a future evaluation and optimizing for performance in the cloud, Dress4Win wants to distribute its system architecture to multiple locations when Google Cloud Platform. Which approach should they use? A. Use regional managed instance groups and a global load balancer to increase performance because the regional managed instance group can grow instances in each region separately based on traffic. B. Use a global load balancer with a set of virtual machines that forward the requests to a closer group of virtual machines managed by your operations team. C. Use regional managed instance groups and a global load balancer to increase reliability by providing automatic failover between zones in different regions. D. Use a global load balancer with a set of virtual machines that forward the requests to a closer group of virtual machines as part of a separate managed instance groups. The correct answer is A. Use regional managed instance groups and a global load balancer to increase performance because the regional managed instance group can grow instances in each region separately based on traffic. Explanation. The current high latency issue occurs because Dress4Win's application is hosted in a single data center. To improve performance across different regions, the best approach is 1. Use regional managed instance groups. MIGs deploy instances in multiple regions. Each region will have its own instance group. Autoscale based on traffic spikes in each region. 2. Use a global load balancer. The load balancer will route user requests to the nearest regional instance group. This reduces latency by serving users from the nearest server. Provides high availability and automatic failover if any region fails. 3. Benefit: improved performance due to low latency access. High availability due to automatic failover. Cost-effective scaling based on traffic. Why other options are incorrect? Option B. Use a global load balancer with a set of virtual machines that forward the requests to a closer group of virtual machines managed by your operations team. Incorrect, because manual management of VM groups by the operations team is inefficient. No autoscaling capability. Higher latency since no automatic scaling occurs. Option C. Use regional managed instance groups and a global load balancer to increase reliability by providing automatic failover between zones in different regions. Incorrect, because while increasing reliability is important, Dress4Win's primary concern is performance, latency, not just failover. The solution must also provide low latency access, which requires deploying instances in multiple regions, not just zones. Option D. Use a global load balancer with a set of virtual machines that forward the requests to a closer group of virtual machines as part of a separate managed instance group. Incorrect, because forwarding requests to separate managed instance groups introduces additional latency. This setup lacks automatic scaling based on regional traffic demand. It also increases operational complexity.